what we want to do is we're looking for the pattern in the numbers. So we're looking at these numbers. Make this a little bigger for you. There we go. Looking at these numbers. So we have 1, 3, 4, 7, 11, blank, 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 and then 123. So what's the pattern? What's going on there that's making that happen?
So if you see 1 plus 3 is 4, 4 plus 7 is 11. So the
Nice.
follow this pattern.
Good, Destiny. Good observation. Yeah, look what Destiny observed. 1 plus 3 is 4. And then if you keep going with that, like 3 plus 4 is 7. Yeah, nice. Probably a lot of you saw that, right? 4 plus 7 is 11. Very good. That seems to fit what we're seeing. Now, what that observation is a good one, and that this is exactly what a scientist does. This is, I like patterns, studying patterns. Probably my favorite part of the course is because that is the heartbeat of math and science. I don't know if you know that, but that's really what math and science are all about, is patterns. If you think about it, all the rules we learn in math and science are just patterns, aren't they? Think about what we just studied recently, decimals, right? We learned that if you have 0.327 repeating forever, that's just 327 over 999. The pattern is you put it over that many nines, right? And if you have another 0 in the front, then the pattern is you have to add a 0 to the back, right? If you have 2 zeros in the front, then you got to add 2 zeros to the back. I'm just bringing up one rule that we studied recently and saying it's just a pattern. You see, it's just a pattern in the end. They're just a pattern. It's just how many things under the bar is how many nines, and then how many zeros here is how many zeros there. It's just a pattern. All the rules in math and science come from observing patterns. That's the heartbeat. That's the central piece of math and science. So you're going to have little future math and science people, STEM people, sitting in your classroom. Science, STEM means science, technology, engineering, mathematics. Little people that are going to grow up to become big people that do those jobs. Now, what is it you're supposed to help them do? What is the central piece of their job? Patterns. Getting better and better and better at observing patterns, describing patterns, predicting patterns, organizing patterns. That is the heartbeat of science, technology, engineering, and mathematics. So good job. This is what is science. What do I mean? It's hard. What does a scientist do? A physicist. Let's just go straight to a physicist. They look at the stars and they also things on the earth, the way a baseball moves, a golf ball, the way cars, engines rev, explosions, sound, light, and they look for the pattern. They look at nature. They look at what God has created and what's happening, and they say, what's the rule behind that? What's the rule causing that to happen? And they find these rules, and it's great when scientists find these rules. It helps our lives immensely when we can, like Einstein said, think the thoughts of God, right? Find out what the rule is that's governing what we see. Well, that's exactly what we're doing here. We're going straight after it in this section and in this part of the course. We're going to practice patterns exactly. Today, it's number patterns. So we're looking and we're saying, okay, what's the pattern? Now, what a scientist does, what he or she does, is they look at what they can see with their eyes, right? They look at nature, or a doctor looks in the human body, and he or she sees how the blood and the pressure in the vessels and the heart and all the things in the body work. And they look at the pattern and they try to figure out what's the rule that causes the blood vessels to do what they do, or the heart to do what it does. What is the rule governing the behavior that we're seeing? And so that's what you and I are trying to do right now with these numbers. And so Destiny has put forward the good observation that the rule seems to be you're just adding the two previous numbers. So that's called a hypothesis or a theory. That's what a scientist comes up with. That's what a biologist, they're trying to come up with vaccines right now for COVID, right? And they're trying to find what's the rule this infection is following so that they can make things that combat that. So my point is, once you come up with a hypothesis or a theory in math and science and engineering and technology, then you need to test it. And the main way you test it is you predict something. Let's see if we can predict the 123. Will it work? Destiny's theory is good if it fits the 123. Let's check it out. So what would be the next one? 7 plus 11 is 18. And then the one after that, let's try it. 11 plus 18 would be, what's that, 29. So far, so good. Okay, and now what's the next one going to be? Looks like 18 and 29 would be, I don't know what, or CF 49, 47, right? 47. Okay, and then the next one, 29 and 47, did you calculate 30, 76. Okay, now here we go. Here's for all the money. Is it true? 47 and 76, do they add up? Let's see, 110. Yep, perfect. So Destiny's theory is right on the money, right? It predicts the 123, perfect. They call that predictive power. A theory, a scientific theory is valid. We believe it to be true if it has predictive power, if it predicts something that we see happen later. That's exactly the heartbeat of how science works.